In section 2.3, we look at the rate of change and the slope of a line. And basically, they are the same thing. So when you have a graph and you move from one point to another point, you can measure the rate of change by comparing the vertical change to the horizontal change. And if you think of that as a line, we call that the slope of a line. And you measure that vertical change by doing the change in y. So that's what we would typically call the rise. And you do the horizontal change by looking at the change in x, which we typically call the run. And we give this the notation delta y over delta x, which means change in y over change in x. Now, the way you actually compute the slope of a line, if you know the 2 points that it passes through, or any 2 points that it passes through, is by subtracting the y values and subtracting the x values, and then taking the quotient of those two differences. So let's look at an example. Over here we have a line that passes through the point -5, 1, and also the point 10, 7. And so if I want the slope of that line, I can use the formula by identifying x1 and y1 and x2 and y2. However, I want to show you a slightly different way to approach this. Allow me to write down the 2 points that the line passes through, which is 10, 7 and -5, 1. And you'll notice that I'm writing one on top of the other. This way, when I go to find the slope, I'm going to subtract my y values in this order, and I'm going to subtract my x values in the same order. And so when I do y2 minus y1, I'm going to do 7 minus 1. And when we do x2 minus x1, we're going to do 10 take away -5. And if you do the math on this, you get 6 divided by 15. And if you cancel the common factor of 3, you get 2/5. Now, one thing I should note here is that it doesn't matter which way you subtract these points. So if we had written the other point on top and subtracted, you would get the same answer eventually in the end. And to further drive this point home, I also want to point out that you could pick any 2 points on the line. So, for example, here's a couple of other points on the line. We have a point here, which is 0, 3, and we have a point over here, which is -10, -1. And you'll notice if I take those 2 points, write them down one on top of the other, then we can perform the subtraction. I always like to subtract going downward. It's easier to remember, I think. But the slope of the line there is y value minus y value, so that's 3 take away -1, divided by x value minus x value. And if you do the math on this, you get 3 plus 1, which is 4. And, in the bottom here, I made a little mistake here. The point over here is -10, so I need a negative there. So just a proof that I am human and do make mistakes. But anyway, if we do 0 take away -10, we end up getting +10. And 4 divided by 10 can be reduced to 2/5. And what you should notice is that you get the same answer no matter which 2 points you use on the line. Okay? And that's because the slope doesn't change. The slope is the rate of change. And for a line, that's always the same no matter what 2 points you pick. So next, I just want to look at some basic concepts pertaining to slope. So anytime you have a line that slopes upward, which means as you read the line from left to right, the line is going up, those lines will always have a slope which is greater than 0. And by the way, something I forgot to mention on the previous page, M is the letter that we typically use to represent the slope of a line. As you move from left to right, if your line is going downward, then the slope will be a negative number. If your line is horizontal, the slope will be 0. And if your line is vertical, it will actually have no slope at all, or sometimes we'll say the slope is undefined. So having a slope that is 0 is very different from having no slope. Okay, next up, parallel lines. If line 1 is parallel to line 2, that means when you graph them in a plane, they look like railroad tracks, for example. Parallel lines have the same slope, so the slope of the first line is equal to the slope of the second line. Perpendicular lines are a little bit more interesting. When line 1 is perpendicular to line 2, that means not only do they intersect, but they intersect to form a 90-degree angle. And in this case, the slope of one of the lines is the negative reciprocal of the slope of the other line. Now, sometimes this can be a little bit confusing here. So another way to think about the relationship between perpendicular lines is that if the slope of the first line is A over B, then the slope of the second line will be negative B over A. And so that's what we mean when we say they are negative reciprocals of each other. Okay? And that's when they're perpendicular. And so we'll do some examples here in just a minute. So let's answer this question. Are the lines AB and CD parallel, perpendicular, or neither parallel nor perpendicular? So here are the points AB, and here are the points CD. So if we want to know if these lines are parallel or perpendicular or neither, we don't need to graph the lines. In fact, graphing is not the answer here because sometimes graphs can be a little bit misleading. All we need to do is find the slope of each of these lines. So for AB, the slope of line AB is equal to, the formula says, subtract the y values, which in this case would be -2 minus 4, and subtract the x values in the same order. That would be 5 take away -3, and then simplify. And so this is -6 over +8, which reduces to -3/4. So this is the slope of the line through A and B. Then we do the same thing for this to find the slope of the line through C and D. So the slope of the line through CD is, once again, subtract. And so we have -1 minus 7 over, and then we're going to subtract the x values, which in this case is 10 minus 4, and we'll do the math. This is -8 over +6, which is -4/3. And now we just need to compare these. Well, are these slopes the same? No, they're not the same, right? So they're not parallel. But clearly we can see that they are reciprocals, yes? One line has a slope of -3/4. The other line has a slope of -4/3. And so you might want to say that these are perpendicular lines. However, if we go back to the last page, perpendicular lines will not only be reciprocals, but they will also be opposites, which means that one has to be positive and one has to be negative. In this case here, both lines have a negative slope, so they cannot be perpendicular. So in this case, they are neither parallel nor perpendicular. So you have to be a little bit careful, because when you first look at those slopes, it kind of looks like maybe they're perpendicular, but actually they end up not being perpendicular. Okay, next up we're going to move on to the next section, which is writing equations of lines. And first up in this section, we're going to talk about the slope-intercept form of a line, which I'm pretty sure most of you have probably heard of before. The equation of a line with a slope equal to m and a y-intercept that is the point 0b is written as y equals mx plus b. And so, as an example, what I'd like to do is write the equation of a line that goes through the point -2, +5, and has a slope of -3 using this equation. And so we know that y equals mx plus b. And so the real question is, we need to know what is the slope of the line and what is the y-intercept. Well, they gave us the slope. So we know the slope is -3, but we still do not know the y-intercept. And you need to be careful here. You cannot just assume that this number is the y-intercept. To be the y-intercept, the x-coordinate would have to be 0, which it isn't. So we're going to start with substituting the fact that we know the slope is -3. We can put that in here. And that gives us y equals -3 times x plus b. Now again, we need to know what b is. We don't know what b is, but we do know that our line passes through the point x equals -2 and y equals 5. And so since it passes through x equals -2 and y equals 5, we can substitute these into our equation. So if I put in y equals 5, we get 5 equals, then we have -3 times x, but x we know is -2, and then plus b. And if we do the math here, we get 5 equals 6 plus b. And if we subtract 6 from both sides, we get -1 equals b. So we now know that b equals -1. So now we can write the equation of the line by taking the fact that we know the slope is -3 and we know the y-intercept is -1. We can combine those together, plug them both back into the equation y equals mx plus b, and that gives us y equals -3x minus 1. So to use the slope-intercept form of a line, you have to know the slope and the y-intercept. And usually one of those two things is not directly given to you, and so that means you need to figure it out. Let's try another example. In this example, we want to write the equation of a line through the points -3, 8, and 5, -4. So in this case, we actually don't know the slope, and we also don't know the y-intercept. So first, let's go ahead and find the slope. Now to compute the slope, remember, we have our slope formula, which says that we need to subtract the y values and subtract the x values and then divide those quantities. Now what I like to do here, of course, is I like to take one of my 2 points and write it underneath the other point. This allows for easier subtraction. And again, that red arrow that I'm drawing here, in case you're wondering why I'm drawing this arrow, I'm indicating that I'm going to subtract the y values in this order, and I'm going to subtract the x values in the same order. And so our slope here is -4 minus 8 divided by 5 minus -3. And if you simplify, you get -12 divided by 8. And if you divide by 4, you get -3 over 2. And so here is our slope. Now, we know the equation of a line using the slope-intercept formula has this format, and we just figured out the slope was -3/2. So next up, we need to know, what does b equal? Well, to get b, we have to plug in a value for x and a value for y. And you have 2 choices, because in the beginning, up here, you were given 2 points. It doesn't matter which point you use. You will get the same answer. So I'm going to pick the first point. I'm going to take those values of x and y and plug them in. So y is 8, x is -3. If I plug that in, I get 8 equals slope, which is -3 over 2, times x, x is -3, and then plus b. Now we need to do the math. So this is 8 equals, now remember, -3 over 2 times -3, we can put over 1 here. So that gives us +9 over +2, just multiplying straight across, plus b. And now to solve for b, we have to subtract 9 over 2 from both sides. And so that gives us b equals 8 minus 9 over 2. Now you can do this on a calculator if you want, but it's not that difficult to do by hand. So I'm going to change 8 to be 8 over 1. And if I multiply the top and bottom by 2 here, that gives us 16 over 2 minus 9 over 2, which is 7 over 2. And so we now have the y-intercept. Now the answer isn't the y-intercept. The answer is the equation of the line, which we know is y equals mx plus b. We know the slope is -3/2. We now know the y-intercept is 7 over 2. And if we plug both of those in simultaneously, we get the equation of our line. And this is our final answer. And so what you can do, if you want to, is you can do the problem again, except this time use the other point. Use the point 5, -4 when you plug in your values here, and verify that you get the same answer. All right, here is another formula for finding equations of lines. It's called the point-slope form of a line. And it says that if you know that a line passes through the point x1, y1, and it has a slope equal to m, then the equation of the line in point-slope form is y minus y1 equals m times the quantity x minus x1. And this equation works for finding equations of lines just like y equals mx plus b. So for our example here, let's find the equation of the line through these 2 points. And if this looks familiar, it should, because this is the last example that we did over here. So we should get the same answer, yes? Okay, so first thing we need to do, we need to compute the slope. So, we'll do this again just for completeness here. Actually, let me do this. Let me bring this point over here. And I'm going to subtract to find the slope. And so our slope will be 8 minus -4 divided by -3 minus 5. And this is positive 12 divided by -8, which is -3/2. And that should look familiar because that is the same result that we got last time. Now, to get the equation of the line, we're going to use the point slope formula, which is here. We know our slope is -3/2, so all we have to do this time is plug in values for y1 and for x1. And you get those by picking either one of the original points. Now, the last time I did this problem, we used the point -3/8. So just to be a little different, let's choose the second point and plug it in. So if we do that, we get y minus y1. y1 is -4 equals the slope, which is -3/2, times the quantity x minus x1, and x1 is 5. And so now we'll just do the math carefully here. This is y plus 4 equals -3/2 times x. So what I'm doing here is I'm multiplying this out. And then we get -3/2 times -5. And so this is y plus 4 equals -3/2 x plus, right, negative times negative is positive, and that's 15/2. And then we'll subtract 4 from both sides. And this gives us y equals -3/2 x plus 15/2 minus 4. Again, 4 is the same as 4/1. So I'll multiply top and bottom by 2 to get a common denominator. And this is -3/2 x. And let's do a little mental math here. 15/2 minus 8/2 is positive 7/2. And that is the same answer that we got on the preceding page when we did it using the other formula. Let me just flash over and show you. Here it is. Same answer. Let me clean this up a little bit. There we go. All right. So in our next example, it's a little bit more complicated. We're asked to write the equation of the line that passes through the point 5, -7, and is perpendicular to this other line. So this is a little bit different because you're not given 2 points to find the line, and or to find the slope rather, and you're also not given the slope of the line. So what we need to do is we need to find the slope of the perpendicular line, and once we have that slope, then we can find the slope of our line by knowing that it's perpendicular. So I know that might sound a little bit confusing. So I'm going to organize this over here by writing the perpendicular line is this line. 10x minus 2y is equal to 4. Now, the way we find the slope of a line is by solving for y. So let's go ahead and solve for y here. So what I need to do to solve for y is subtract 10x from both sides. This will give us -2y equals 4 take away 10x. And then I'm going to divide by -2 to everything. And that gives us y equals -2 plus 5x, Now keep in mind that this is the same as 5x minus 2. Now what I'm doing here is I'm writing this line in the format of y equals mx plus b, because when it's in this format, whatever number is in front of x, that is your slope. So the slope of the perpendicular line is 5. Now, that's the perpendicular line. We need to find the slope of our line, which is the line that goes through this point and is perpendicular to this one. So the fact that we know the slope of this line, the perpendicular line, is 5, then that is the negative reciprocal. And the reciprocal of 5 is 1/5, so the negative reciprocal is negative 1/5. So now we have the slope of our line and the point that it passes through. And I can find the equation of the line by using either formula. To be honest with you, I prefer using the point slope formula. And all I need to do now is plug in the slope and plug in the point. And when we do that, we get y minus negative 7 equals negative 1/5 times x minus 5. And this is y plus 7 equals negative 1/5 times x. And then negative 1/5 times negative 5 is positive 1. And if we subtract 7 from both sides, we end up getting negative 1/5 x minus 6. And so this is the line that passes through this point and is perpendicular to this line. Now, one other thing to keep in mind here, I don't mean to keep piling it on, but sometimes when you get an answer, they'll ask you to answer in standard form. Now, standard form, remember, we went over that in a previous section. Standard form means they want you to write your answer like this. So we have the right answer, but if they want it in this standard form, then what we need to do is get the x's and the y's on the same side of the equation. So we have our equation. What I'm going to do is take this term and add it over to the left side, which makes it become positive 1/5 x plus y equals negative 6. And the second thing you need to do is multiply it by 5, because we don't want to have fractions when putting it in standard form. And if you do that, then this is the equation of your line. And what's really important to understand here is that both of these answers are the same. They're just in different formats. But sometimes they will ask for your answer in different formats, and so you need to be prepared to give them the answer in the format that they want. Okay, for our last example, we're going to use a line to model a problem. So here it says a car was purchased for $25,500 in 2015 and is now worth $13,100 in 2020. Find a linear depreciation model for this car. Okay, so that can sound a little confusing, but let's pick it apart a little bit. So we have two variables here. We have time and we have value. And time will be represented by the variable x, and value will be represented by the variable y. Now, for time, we don't want to state time in terms of years. You can, but it's just not desirable to do that. Instead of saying 2015 for the time here when the car is brand new, let's associate a brand new car with being time equals 0. It's when you first buy the car. So when x is 0, which represents the year 2015, the value of the car is $25,500. Now, 5 years later, in 2020, that time will be represented by 5 because it's 5 years after 2015. And the value of the car here is $13,100. So what you have now basically are 2 points. You have these 2 points. And so if you want to find a linear, which just means line, depreciation model, we need the slope of the line. And we get the slope of the line by subtracting the y values and subtracting the x values and dividing. So that's 25,500 minus 13,100 divided by 0, take away 5. This is equal to 12,400 divided by negative 5. And this is equal to negative $2,480. That's your slope. Now remember, slope is also rate of change. And this is a practical problem. So that number means something here. This is not just a number for the sake of being a number. That number represents how much money the car goes down in value each year that passes by. That's what that slope represents. It represents the change in y divided by the change in x. And remember, y is the value, that's money, and x is time, that's years. So this is negative $2,480 per year. Now, to find the equation of the line, we can go ahead and use our formula for doing that. I'm going to pick the first point to plug in. So y1 is 25,500. Slope is negative 2480. And x1 is 0. And when you multiply this out and add 25,500 to both sides, you get a linear depreciation model for this car. Now, what's significant about this is that you can use this model to predict what the car will be worth at a different time. So just to add on to this question, I could ask something like, what is the value of the car in the year 2023? And so first of all, we would say, well, 2023 is 8 years after 2015. So this is when the car is 8 years old. And then we could just plug in x equals 8 into this equation. And if we do the math there, we get $5,660. Not worth very much after 8 years. Okay, so now you should be ready to do the homework for sections 2.3 and 2.4. So let's get after it.